There is a place that exists just beyond the edge of what most people think is possible. A place where the lights are always on, where the floors are always clean, where every single movement has a purpose, and where not a single human hand touches the product from the moment raw material enters to the moment the finished piece leaves. No workers, no breaks, no mistakes, just the quiet, relentless, almost meditative rhythm of machines that never stop, never tire, and never wonder if they are doing it right, because they always are. This is not a factory from a science fiction film. This is not a concept. This is not a prototype. This is real, and it is already running, right now, somewhere in the world, producing things you use every single day, guided entirely by artificial intelligence, and watched over by no one. Step inside. The doors open automatically, of course. There was never going to be someone standing there to greet you. The first thing you notice is the light. Cool, even, and impossibly precise. Not the harsh fluorescent buzz of an old warehouse floor. This light has been calculated. Every lumen placed with intention, every angle designed to eliminate shadows that could confuse the vision systems that are watching everything, always, from every direction. The ceiling is a grid of sensors, cameras, and emitters, and together they form something closer to a nervous system than a lighting rig. The air is filtered, temperature-controlled, and carries a faint electrical scent. Not unpleasant, just clean in a way that feels almost clinical, almost sacred. The floor beneath you is a smooth, sealed composite, light gray and flawless, marked only by the painted paths of the autonomous guided vehicles that move through this space like blood cells through a vein, each one knowing exactly where it is, where it needs to go, and how to get there without ever colliding with another. You watch one pass close to you, carrying a tray of components so small they catch the light like grains of metal sand. It does not slow down. It does not acknowledge you. It simply moves, efficient and certain, part of a choreography that has been running since the first morning this facility came online. Somewhere deep in the building, a server processes 40,000 data points per second. Temperature, pressure, vibration, torque, position, speed, material composition, air quality, power draw. Every machine in this facility is talking constantly in a language of numbers and signals, and the AI is listening to all of them at once, understanding all of them at once, making decisions based on all of them at once. It adjusted the speed of a conveyor belt 4 minutes ago because a sensor detected a 0.3-degree increase in ambient temperature near a thermal-sensitive assembly station. No human noticed. No human needed to. The system handled it before it became a problem, the way it always does, the way it was designed to do. At the far end of the entrance corridor, the first great hall opens up, and the scale of it stops you for a moment. The ceiling climbs 30 meters above the floor. Rows of robotic arms stretch in both directions, each one mounted on a track that allows it to travel laterally, vertically, and rotationally with a range of motion that no human arm could ever match. They are not the heavy, brutish industrial robots of older factories. These are slender, articulated, precise, almost elegant. Their joints move with a smoothness that feels almost biological, and their end effectors, the tools they use instead of hands, change automatically depending on the task, swapping in milliseconds from a vacuum gripper to a torque driver to a laser alignment tool, without any pause, without any hesitation. You watch one of them pick up a component so small it is invisible to you from this distance. It holds it for exactly the time required to perform a quality inspection. Cameras embedded in its wrist scanning the object from 6 angles simultaneously, and then it places it down with a precision measured in micrometers. The whole motion took less than 2 seconds. The arm is already reaching for the next one. Across the hall, another cluster of arms works in perfect synchrony on a larger assembly, their movements interlocked like the teeth of a gear, each one performing its part of a sequence that was not programmed by a human engineer sitting at a workstation over the course of weeks, but generated by an AI system that analyzed the task, modeled thousands of possible approaches, and selected the optimal one in the time it takes you to blink. If a better method is discovered during operation, and it often is, the system updates itself. Not tomorrow, not after a maintenance window. Now, the optimization is constant, and it never ends. On the floor level, the autonomous guided vehicles continue their endless routes. but now you can see the full complexity of the network they form. There are dozens of them, maybe more, each one a different size and configuration depending on what it carries. Some are flat platforms, low to the ground, transporting large sub-assemblies between stations. Others are tall, enclosed carts, moving finished components to the packaging zone with a gentleness that borders on reverent. They communicate with each other and with the central system in real time, negotiating paths, yielding right-of-way, rerouting when a station downstream signals that it needs a different sequence of deliveries. None of this was manually scheduled. The AI manages the logistics the way a brain manages breathing, automatically, continuously, without effort, and without ever needing to be told to keep going. You move deeper into the facility, following one of the painted path lines along the floor, and the sound changes as you walk. In the first hall, it was a high, clean hum of servo motors and the soft whisper of filtered air. Here, closer to the material preparation zone, there is more weight to the sound, a deep, rhythmic pulse of forming equipment, the sharp hiss of a pneumatic system releasing pressure, the low resonance of a large press cycling through its operation with a patience that feels almost geological. The material here is metal, sheet stock, fed from enormous coils that unwind with a slow, majestic tension, the steel catching the overhead light as it moves forward along the processing line. Its surface unmarked and perfect, a blank page waiting for the machine to write on it. The first process is cutting. A laser head moves above the sheet with a speed and fluency that is almost impossible to follow with the naked eye, tracing paths that were defined not by a human operator drawing lines on a screen, but by a generative design algorithm that optimized the cut layout to minimize waste to a fraction of a percent. The laser does not hesitate at corners. It does not slow down for curves. It simply moves, burning clean lines through 3 millimeters of steel as though the material were paper, the cut edge so precise that under magnification, it looks like it was polished rather than cut. Tiny jets of gas blow away the smoke and residue in real time, keeping the work area clean, keeping the sensors unobstructed, keeping the process moving without interruption. The cut pieces drop away from the sheet and are caught by a sorting system below the cutting table, separated by type and size and destination without any human involvement. Each piece tagged electronically and tracked through every subsequent operation by the central AI until it exits this building as part of a finished product days or hours from now. From cutting, the metal moves to forming. Here, the press brakes are fully automated, the back gauges moving to the exact position for each bend without operator input, the ram descending to the calculated pressure with a precision that eliminates spring-back compensation as a human skill and converts it into a known variable that the machine accounts for automatically, every time, on every part. A vision system mounted above each press confirms the angle of every bend before the part moves forward, not as a final check performed by a quality inspector at the end of the line, but as an in-process verification that feeds back into the forming parameters in real time, adjusting the next hit before it happens if any deviation is detected. The sound of the press is deep and satisfying, a solid, definitive thud that carries weight and certainty. Each bend is a commitment, and the system only commits when it knows it is right. Beyond the forming area, the facility opens into a vast joining and assembly zone, and here the complexity reaches a level that is genuinely difficult to absorb all at once. The space is divided into cells, not physical enclosures, but defined zones that each autonomous system understands as its operational domain. In one cell, a welding robot moves along a seam with a steadiness that no human welder could sustain for more than a few minutes, maintaining a perfect arc length and travel speed across the entire joint, the weld pool glowing orange-white in the tight controlled atmosphere of the welding enclosure, the finished bead emerging clean and consistent and strong. In the adjacent cell, a collaborative robot, smaller, lighter, with rounded edges and a safety rating that allows it to work in close proximity to the rare human visitor, performs a delicate sub-assembly operation, threading components together with a touch sensitivity that comes from the force torque sensors in its wrist, feeling for alignment the way a skilled craftsperson would, adjusting its grip in real time based on the feedback it receives from the part. The AI that runs this zone does not just tell each robot what to do. It watches them do it, evaluates the outcome, learns from any variation, and incorporates that learning into every future operation. It is not learning the way a software update learns, as a discrete event that requires downtime and deployment. It is learning continuously, in the background, while the work continues uninterrupted. Every completed part is a data point. Every successful operation is a refinement. Every micro-variation in material or environment is an opportunity to improve. The system is, in a very real sense, getting better at its job right now, while you watch. Moving through the assembly zone, you pass a station where two robotic arms work together on a single component. Their movements perfectly coordinated despite the fact that they are separate systems. Their collaboration orchestrated by the central AI, the same way a conductor coordinates an orchestra, not by doing the playing itself, but by understanding the total structure and ensuring that every element arrives at the right moment, in the right condition, to contribute to the whole. One arm holds a structural frame steady, while the other drives fasteners with torque values that are verified in real time against a digital specification sheet that was itself generated by a structural analysis AI running upstairs in the server room. The fasteners go in at the correct torque. Every one of them. Always. There is no such thing as rework in this facility. Not because problems never arise, but because the system detects and corrects them before they become problems. The quality assurance here is not a department at the end of the line. It is woven into every single operation, running in parallel with production, invisible and constant, the way an immune system runs in parallel with normal life. Not noticed unless you are looking for it, but always working, always protecting the integrity of the whole. In the inspection zone, the scale of the quality system becomes more visible. Here, finished subassemblies move through a gauntlet of metrology equipment that would have been considered extraordinary laboratory hardware just a decade ago, now installed as standard production equipment in a factory that never stops. A coordinate measuring machine arm sweeps around a complex housing, its ruby-tipped probe touching reference points in a sequence defined by a measurement program that was written by an AI after analyzing the engineering drawing and determining the optimal inspection strategy based on the part's critical features and its downstream function in the assembly. The measurements are completed in under 90 seconds. The results are compared automatically to the tolerance specifications. The part is passed or failed without any human involvement, and if it fails, which is rare, because the upstream processes have already eliminated virtually all variation, it is routed to a separate area where the AI diagnoses the cause of the out-of-tolerance condition, traces it back to its source in the process, and initiates a corrective action that prevents recurrence before the next part has finished forming. You watch a 3D scanner complete a full surface scan of a formed sheet metal panel in under 40 seconds, capturing millions of data points and generating a color deviation map that shows exactly where the actual surface differs from the nominal CAD model. The deviation is measured in hundredths of a millimeter. The maximum deviation shown on the map is 0.07 millimeters, a distance smaller than a human hair, and it is coded amber on the map, meaning it is within tolerance but approaching the limit. The AI flags this. It does not stop production. It does not raise an alarm. It simply notes the trend, correlates it with a slight wear pattern it has detected in one of the forming tool sensors, and schedules a predictive maintenance intervention for the next planned production pause, which, in this facility, happens not because a machine broke down, but because the AI determined 3 days in advance that a particular component was approaching the end of its optimal service life and arranged for its replacement during the lowest impact window in the production schedule. The machine will be serviced before it fails. It always is. Further along the production flow, the surface treatment area hums with a different kind of energy. Here, the parts move through automated cleaning systems that prepare their surfaces for coating. Ultrasonic baths, spray wash systems, air knives that blast every water droplet from every surface geometry with precise directional control, and then enter the coating line, where robotic spray systems apply finishes with a consistency that eliminates the variability that was once inherent in human spray application. The spray pattern, the distance from the surface, the gun speed, the overlap between passes. All of these parameters are controlled by the system and verified by sensors measure wet film thickness in real time, adjusting the application on the fly to compensate for any variation in the incoming part geometry or the ambient conditions in the booth. The finished surfaces emerge from the curing oven with a gloss and uniformity that would be difficult to achieve in a traditional production environment and is almost trivially reproducible here because the process is defined by physics and chemistry and controlled by a system that understands both completely and applies them consistently every time. Near the end of the production line, the packaging zone operates with a quiet efficiency that feels almost anticlimactic after the visual intensity of the upstream processes. But look closer, and the sophistication is just as deep. Robotic pick-and-place systems select finished products from trays, inspect them one final time using integrated vision systems, orient them for packaging, and place them into boxes with a care that seems almost deliberate, almost gentle, as though the machine understands the value of what it holds. The boxes are sealed, labeled with barcodes that carry the full production history of every component inside, every measurement, every process parameter, every quality check, all traceable back to the raw material, and placed onto pallets by a palletizing robot that builds the stack according to an optimized pattern calculated to maximize stability during transport while making the most efficient use of pallet space. The pallet wrapping machine spirals film around the finished load in a tight, precise helix, the tension calibrated to hold everything secure without deforming any outer packaging. And the completed pallet moves to the outbound staging area on an autonomous conveyor that has already received instruction from the warehouse management system about where it needs to go and when it needs to be picked up. Everything is connected. Everything is tracked. From the moment the raw material coil was unwound at the start of the line to the moment this pallet enters the loading dock, the AI has followed every piece of material through every transformation, recording every measurement, logging every decision, building a complete and unbroken record of the entire production journey. If a customer ever needs to understand what happened to their product during manufacturing, the answer is available, completely, instantly, in more detail than any human-run system could ever provide. The server room, tucked behind a climate-controlled partition near the center of the facility, is the true heart of this place. Here, in racks of processors and storage that draw a steady, enormous amount of power and exhale it as carefully managed heat into the cooling system, the intelligence that runs everything lives. It is not one system. It is many specialized models for vision, for motion planning, for predictive maintenance, for quality analysis, for logistics optimization, for management, all coordinated by an orchestration layer that ties them together into a coherent operational intelligence, each one an expert in its domain, all of them contributing to the performance of the whole. The AI does not experience the factory the way you do. It does not see the light catching the surface of a cut steel sheet as beautiful. It does not find the rhythm of the press brake satisfying. It does not feel anything at all. But it knows this facility in a way that no human ever could. Every machine, every sensor, every parameter, every trend, every anomaly, every opportunity for improvement. It knows it completely, and it runs it perfectly, and it never stops. Outside, the sky moves through its natural cycles. Day becomes evening. Evening becomes night. The world beyond the facility walls follows its human rhythms. Meals, rest, the ordinary cadence of biological life. Inside, nothing changes. The lights stay on. The robots continue their movements. The AI processes its endless stream of data. The products continue to be made. When the morning shift at a traditional factory would just be arriving, the first cars pulling into the parking lot, the first coffees being poured, the first conversations of the day beginning, this facility has already completed another full cycle of production, uninterrupted, unattended, and essentially perfect. There is something profound about standing inside this space and understanding what it represents. Not just the technology, the robots and the AI and the sensors and the software, but the idea that the things we make can be made with a precision and consistency and efficiency that human hands and human schedules could never fully achieve, not because humans are inadequate, but because some tasks are simply better suited to systems that do not fatigue, do not vary, do not need to eat or sleep or rest, and do not experience the 1,000 small fluctuations that make human performance inherently and beautifully variable. This is not a replacement of human ingenuity. The intelligence that designed these products, that conceived of this facility, that developed the AI systems that run it, that made the decisions about what to make and why. All of that came from human minds. What has been replaced is the repetitive, physically demanding, cognitively exhausting work of standing at a machine for 8 hours and doing the same operation thousands of times, watching for deviations that a sensor can detect 100 times more reliably. The humans who created this factory are somewhere else now, designing the next generation of products, developing the next version of the AI, planning the next facility, solving problems that have never been solved before, doing the work that only humans can do. Here, the machines carry on. The AI continues to learn. The products continue to flow. And the factory, silent, illuminated, endlessly productive, runs through another night without any of it maturing, without any of it slowing, without any of it ever needing to be told to keep going. This is the factory that needs no workers. This is the production line that takes no breaks. This is the future that is already here, already running, already making things in a building somewhere in the world right now, under lights that will never be turned off, watched by cameras that never blink, guided by a mind that never sleeps. And somewhere in the rhythm of its operation, in the sweep of a robotic arm, in the precise path of a laser, in the soft movement of an autonomous cart along a painted line on a perfect floor, there is something that almost feels like purpose. Not because the machine knows purpose, but because we gave it one, and it has never stopped pursuing it. Not for a single second. Not ever.